All right, let's talk about some of the most mind-bending science happening anywhere on the planet. We are diving deep into CERN to break down their latest discoveries and what they mean for, well, pretty much everything.
I mean, really think about that for a second. What if the universe we see, the rules we think we understand, are just one small piece of a much, much bigger picture? It's a huge question, right? And it's exactly that question that's driving scientists to the absolute edge of what's possible.
And that edge is located deep, deep underground. This is where the real action is. In these massive tunnels, scientists are running one of the most incredible experiments ever conceived. A hunt for new particles, new forces, maybe even a whole new understanding of reality itself. So how do you even begin to do something like that? Well, you're going to need a very, very special kind of tool. And that brings us to, quite literally, the most powerful machine ever built.
This is it, the Large Hadron Collider. You've probably heard it called the LHC, but honestly, the name doesn't even do it justice. The sheer scale of this thing is just mind-boggling. It's a modern wonder of the world, built for one purpose: to answer those huge, fundamental questions.
And when I say scale, I mean it. To give you some perspective, the main ring of the LHC is 27 kilometers around. Think about that. It's a giant circular racetrack for subatomic particles, buried hundreds of feet beneath the French-Swiss border. It's an absolutely immense stage for the tiniest things in existence.
So how does this whole thing work? Well, in a nutshell, it's a three-step dance. First, they take protons and accelerate them around this massive ring until they're traveling at, get this, 99.99% the speed of light. Then, step 2, they slam these super fast beams of protons into each other head-on. The energy in that collision is just incredible. And for a split second, that energy can create brand new exotic particles. Finally, step 3. Gigantic detectors, basically the most advanced cameras ever built, capture all the debris so scientists can piece together exactly what happened in that tiny, tiny fraction of a second.
And you know what? All of this particle smashing is paying off. It's led to some absolutely fascinating results, including a very recent and, well, very exotic discovery. Out of trillions upon trillions of these collisions, the detectors caught a glimpse of something special, something so incredibly rare that it's a huge deal to have finally pinned it down.
What they found is something called a doubly charged baryon. Okay, I know, that's a mouthful, but think of it like this. Protons are made of even smaller bits called quarks. A baryon is just a particle made of 3 of these quarks. But this one is special, because 2 of its quarks are a very heavy, very rare type called charm quarks. Finding one of these is like finding a specific needle in a haystack the size of a planet. It's just that hard to produce.
Okay, so why should we care? What's the big deal? Well, seeing how these super heavy quarks get stuck together gives us this amazing, unique window into something called the strong force. That's the literal glue holding the universe together at the atomic level. By creating this rare particle, scientists can really stress test their theories about how matter works. It's a big win.
But here's where it gets really interesting. This discovery, as exciting as it is, actually highlights this huge tension in physics right now. Because this particle, it fits perfectly into our current theories, and believe it or not, that's kind of part of the problem.
This is the great paradox of modern physics. We have this incredibly successful theory called the Standard Model. It describes all the particles and forces we know about, and every time we test it, it passes with flying colors. Discoveries like this doubly charged baryon just confirm it again. And yet, we know for a fact that it can't be the whole story. And this really gets to the heart of it. On one hand, you've got the Standard Model. It's beautiful. It works. Everything it predicts, we find. But on the other hand, you have these massive, colossal mysteries it can't explain at all. I'm talking about things like dark matter, the invisible stuff that makes up most of the mass in the universe. The Standard Model has absolutely no idea what it is.
It really is the multi-billion-dollar question, isn't it? If our best theory is so good yet so obviously incomplete, what is that missing piece of the puzzle, and how on earth do we find it?
Well, the folks at CERN think they have an answer. We need more power. We need more data. And that brings us to the next evolution of this incredible machine.
Get ready for the High-Luminosity LHC. You can just think of it as LHC 2.0. It is a massive, ambitious upgrade designed to push way beyond what the current machine can do and take us into totally uncharted territory.
Now, this upgrade isn't about making the particles hit harder. It's about making them hit more often. The High-Luminosity LHC is designed to produce 10 times more collisions than the current version.
Why? Because more collisions means a much, much higher chance of seeing those super rare needle-in-a-haystack events that might just break our current theories wide open.
And with that absolute flood of new data, who knows what we could find? We're talking about witnessing processes so rare we've never ever seen them before. We might see the very first signs of brand new physics beyond the standard model. And maybe, just maybe, we'll finally get some real clues about what dark matter is or if there are other hidden dimensions out there. The possibilities are just incredible.
Honestly, all of this means we are standing right on the edge of a brand new era in physics. The work being done today, right now, is setting the stage for the next great scientific revolution.
The upgraded machine is going to be firing up soon, and with every single collision, we get another lottery ticket. Another chance to see something no human has ever seen before. The next breakthrough isn't a matter of if, but when. And the only question left is, what secrets is the universe still hiding from us?